So we are dealing with problem number 2.30 of I.E Irodov. The problem is stating what amount of heat is to be transferred to the nitrogen in the isobaric heating process for that gas to perform a work of 2 joule. So let's get started with the problem. So the problem is the easier one. So the nitrogen gas is an diatomic gas. So we have nitrogen gas which is diatomic in nature, and we are here to calculate the amount of heat energy which is needed to perform a work done of 2 joule in the isobaric process. So for isobaric process, if we write the ratio of dq is to du is to dw, then we can say that for an isobaric process dq is equal to n cp dt, du is equal to n cv dt, and work done can be written as pdv. Now since the process is isobaric in nature, so we can say for isobaric process, pressure is constant, and hence if we write the equation PV equals nRT, then if we write the differential form, then we write PdV plus VdP equals nRdt. Now since pressure is constant, so dP is equal to 0. So over here we can definitely say that this part VdP will turn out to be 0, and therefore PdV can be written as nRdt for isobaric process. So if we use this expression over here in the first equation which we have, then we can rewrite this as dq is to du is to dw, dq is to du is to dw as ncp dt is to ncv dt is to nRdt. So what we have done is we have replaced pdv with nRdt, and then the equation looks like cp is to cv is to r, and then we can write r as cp minus cv. So since cp minus cv equals r, so we are writing this r as cp minus cv, and then if we divide by this cv, so we get the final ratio as cp by cv is to 1 is to cp by cv minus 1. That is, we can write this one as gamma is to 1 is to gamma minus 1. Now since we have nitrogen gas which is diatomic in nature, so for a diatomic gas, gamma is equal to 7 by 5, and hence we can write this ratio as 7 is to 5 is to 2. Now over here in the problem, we are asked to calculate the heat that is to be transferred, and the work done is 2 joule. So work done is 2 joule and heat is to be transferred, that is dq is to dw is equal to 7 is to 2, and since work done is 2 joule, so therefore heat energy transferred so from this ratio we can say that the heat energy transferred is 7 joule. So this is the final answer for this problem number 2.30.